today we are going to do something interesting. We are going to deep dive into something, come back out, go back to the basics, and then you get to question the people who built some of the technologies I'm going to show you. So I have the easy job today. So we'll see how that goes. So let's start thinking about some of the trends that some of you are seeing in your own network, sort of for your own services. One of our cloud customers, for example, their entire service was a single monolith, and it used to take them about 3 months to ship out a single change. And what they did is they took this monolith and they chopped it up into about 80 microservices, and the time to release something went down from 3 months to a week. So it's not that people care about microservices or they care about all of these technologies. What they really care about is what it brings them. The second trend, which you probably already noticed or are facing, or based on whatever deployments and services that you have, it's that hybrid multi-cloud and public cloud and Google Cloud are here to stay. So, and this could be simply because you're migrating to the cloud, you're not going to make the migration in one shot, or it may be that you want to actually keep some of these systems on-prem. And then in the third case, it could be that you want to leverage the best of every public cloud and whatever they have to offer. And so you may be deploying your services on-prem or in a private cloud, in Google Cloud, and in another cloud. So the thing that we've been thinking long and hard this last year is how can we make it easy for you to go deliver hybrid and multi-cloud services where you're literally not toiling over the infrastructure that's actually needed to make this happen. The first thing that's actually needed to make this is to remove, like, look at your service. You're essentially crafting each service piece by piece today. And the first thing that you want to do is remove all of the common code out of your service. This would be typically networking code which involves load balancing, or there's fault injection, or failure recovery. It depends on what all you're adding to your services. So what if we removed all of this and then encapsulated it into a simple component that you could just add to your services without bothering to write in all of these primitives inside your services themselves? And then the second thing is, so once you've done that, who's going to go manage all of these services? And that is where you need services management infrastructure, and it's basically not something you want to manage yourself. So you want a fully managed services management infrastructure. So I thought, let's do something fun. Let's actually go and build out, let's say, a summer shop, because it's pretty hot, not in San Francisco, but otherwise. And if you think of a typical web-facing app, you would have a front end, and you'd likely have a shopping cart service, which is along with your catalog, and then you would have some sort of a payment gateway or a payment system. So let's call this our summer shop, and we have our 3 services. Typically, a user's traffic would go in that order, which is user to front end to shopping cart to payment. Now, one of the nice things that have actually come to the forefront, I would say, in the last 1 year, or probably a little bit more than that, is this concept of a service mesh. So, and you will hear us talking about it a bit more as we go throughout the session. But if you had to think of service mesh in a very simple way, it's like this. So imagine your infrastructure that existed, let's say, 10 years ago. Everything used to be a one box, and you bought it. Now you're doing the same with services. Everything is bundled together. So what service mesh is trying to do is actually decouple that. So if you look at your, let's say it's a pod or a VM, and on there, all you want to do is, on your end, you just want to write the service software. And what you want somebody else to do is to write all of the common software, which would be load balancing, which would be, let's say, service authentication. Maybe you're doing some sort of testing, so timeouts, retries, all of the failure recovery mechanisms. So that's what you see on the bottom half of the service mesh. What you see, a very critical component of this is the service proxy, which we'll talk about a bit more. That's essentially doing a lot of the heavy lifting of whatever your services are doing today. The service part of it is simply your either application logic or your business logic. And then the green thing that you see at the top is your service mesh control plane. And this is the thing that's going to talk to your proxies. This is the thing that's going to deliver intelligence to your proxies. This is the thing that's going to absorb things related to observability. So if you had something like this, as you can imagine, the gray box is all you need to focus on, and rest of it is taken care by your services management infrastructure. Now, this is where Envoy comes in, and we are really fortunate to have Matt Klein from Lyft here. We will ask him all the tough questions later, but the Envoy proxy is actually a very key part of this infrastructure. And if you think of the service proxy that you saw on the previous slide, it's basically Envoy that fulfills that function in here. So we use Envoy in addition to all of the technologies that we already have, which is our compute engine, Kubernetes engine. You heard of GKE on-prem, and then there's our cloud load balancing. So if you took a closer look at Envoy, what is it that you see inside? Basically, first of all, this was developed by Lyft, and it is also battle-tested at Lyft, so it's already a hardened proxy. And the things that we really like about Envoy, first of all, it is high-performance native code implementation. Then it also provides eventually consistent service discovery, and we'll ask Matt why that's important. Then it's also API-driven, which was really important to us because we almost view it as an integral part of our, as you saw, the service mesh and then the service management story, and it had to be API-driven for that to be effective. It's also extensible with this notion of filters. I'm sure Matt will touch on it a bit more. One of the nice things is that several of these protocols, such as HTTP2, are built into Envoy, so it supports them from the get-go. So that's, again, important because that's what helps you bring in some of the modernization into whichever services that you have today. And the most important thing is it was designed for observability. A lot of times, all of us add in observability as an afterthought. And I think that is why a lot of our services are these silos, and we really don't get an end-to-end view. So if you think about all of this, now this is what it would look like if we added the proxy into our services. And you can see that now each of our services, these are either VMs or containers, whatever your favorite stuff is. And then we added a service proxy on each of those instances that's running each of those services. Now, this is the cool part. So we are really excited to announce Traffic Director. Traffic Director is a new service which is going to take away some of the toil of going and managing all of these services. So like I said before, what you really want to focus on is your either application logic or your business logic, and you want Google to basically take care of the rest, Google and then the service proxy. And so that is where we are going with all of this. So this is now available in alpha. You're the first people who are actually hearing about it. So what exactly is it? First of all, it's a GCP managed service. Then you can think of it almost as an enterprise-ready control plane for all of the service proxies we spoke about. And the nice thing is that you had a service mesh which could extend to a zone. We are going to let you extend your service mesh across regions. So that is what, like you're very used to our global load balancing with a single VIP. Imagine that you brought that same concept to microservices, and then you have the same things that you get with global load balancing as you get with our external one. The other nice thing is that Traffic Director will also health check all of your proxies for you, which means each proxy doesn't need to health check each other. So you have distilled down the n-square health checking problem, and you've just simplified and outsourced that to the Traffic Director. So I would say like the two main things that you want to think about are global load balancing, health checking at scale, and then the third thing is everything, like auto-scaling, which is typically available for all of our services. So based on traffic signals, this will go and actually scale your backends as well, whichever ones are running the service. So if we add a Traffic Director, that is where it would go to. One of the things that we really wanted to do was to use open APIs between the Traffic Director and the service proxy. And so we use the XDS v2 APIs, and we'll talk about those as well. And then if you look at this picture, essentially the green box is managed by us, and then the proxy is the one that's taking all of your networking code, and then it's sitting next to your application or business logic and making things much, much simpler for you. So I spoke a little bit about global load balancing, and what does that exactly look like? So this is what we are going to go and look at, which is the service that we spoke about. I have three services: the web front end, the shopping cart, and the payment. If you can see the first blob, that is essentially your web front end. And these are not two separate things, one sitting in Singapore region and one sitting somewhere in the US. This is actually one service with just instances sitting in these two different regions. Same for shopping cart, and then same for the last service, which is payment. So what did we do so far? We put in a proxy. We put in Traffic Director. And the moment we put in Traffic Director, we could go expand our service beyond a single region. Otherwise, if you did it on your own, you would pretty much be in a single region. But Traffic Director enables you to go and then spill over or even fail over across regions. So I thought, let's take a quick look at a live setup. I'm going to ask our folks to switch me to the demo, and we'll also pray to the demo gods. Can you? OK, that's there. So this is essentially our summer shop, and we have got some interesting things that we want to sell, including, I just noticed this morning, a very expensive popsicle, which costs $300. But what you're seeing here really is that this is you remember we talked about the 3 services, and the first service is the one that is in US Central. This is our front-end service. Now let's buy the expensive popsicle now that we talked about it. So if you now, let's say, click this one, and what you will notice is this is a small blob here, which is a little bit cut off. But that's our shopping cart service. Again, the instances here are the ones in US Central. And the reason is because I'm right here, and our other set of instances were in Singapore. So obviously, the instances in US Central, which is in Iowa, are closer to me. And then obviously, we have a lot of money to spend, so let's go buy the $300 popsicle. And what you will notice is that the payment service that it went to is actually this US Central 1C as well. So if you go back to the diagram I just showed you before, and let me show you the back end of this a bit. Now, one of the things about the way we set up is, let's go back in here. So these are all the instance groups. These are literally the managed instance groups running each of your services. So what you see in here essentially is the first thing that you would see is our front end, which is 2 instance groups. Then the second thing you would see our cart, which is 2 instance group, 1 in each region. And then the third thing would be our payment, again, 1 in each region. And the last thing is simply because I want to masquerade as a client from Singapore. So that's just one setting in there. But what you would really want to look at is go to network services and then look at your load balancing. And this is where you would see 3 services. And if we go actually to the backends, you can see that this is the front-end service. Then this one is essentially the BS1 is the shopping cart service, and then the last one is the payment service. So this is what it looked like when we were actually accessing it from here. And then the last thing that we would want to do, we can try it live and see. So I wanted to literally do everything from scratch. So this service now, this is basically a client that's going to sit in Singapore. And OK. So maybe it's not connected. So there is a client that's sitting in Singapore. And what we really want to see in here is, would the client in Singapore actually go in there? And we'll see if it wants to go there or not. If not, we'll see it on the console. OK. So I think that might be because it's their setup. But let's go back and take a look at this one. So I wanted to actually take you back again to when we were in the summer shop, if you looked at this one here. What you can see in here is these instances in here, the payment in South Asia. So when we come in as a client from South Asia, you would go back and first hit the front end in South Asia, and then you would hit the shopping cart in South Asia, and then you would hit the payment service in South Asia. So I wanted to switch back to the slides because I wanted to show what that would look like. Can we get the slides back? Yeah. OK. So why is that important? And the reason it is important is for this reason, which is if you look at, if something were to happen to, let's say, all of your instances in the middle region, if something were to happen to that, your first service can actually go and fail over to the shopping cart that's actually deployed in the second region. And then let's say there is something that happens with the shopping cart service in that region because, for instance, it's just not able to scale up. Then it would go and it can access the service that's in the other region. So just like you're used to global load balancing, which is available for your external services, you get the same capabilities with Traffic Director for your own internal services as well. And this is some of the other config that I abstracted out. You generally won't have to configure all of this by the time you folks get to using this. But this is some under-the-hood configuration where you essentially set up Traffic Director for your services. And then you also went, and if you see at the bottom, you can see the Envoy is running on an instance. So this is just a snip of one of those instances. So we spoke about all of this, and now we are going to speak about something that you've been hearing throughout this conference, which is Istio. And if you look closely at Istio, I think all of you are mostly going to be familiar with Istio. But what you get is service discovery. You get security, instrumentation. You get client-side load balancing. For those of us who have come from the traditional load balancing world, it is a bit of a change, because you're always used to the server side doing the load balancing. And here, you have the client side that has the intelligence to pick the right backend. And then, of course, you have things such as circuit breaking, and you've got dynamic routing, and so on and so forth. Again, building on the theme of observability, you can do observability end-to-end using Istio. And then you obviously have MTLS-based security and several of the other features that you'll hear talked about in these sessions. One of the nice things about Istio is that you can use it with Kubernetes or GK, but you can also use it with VMs. So as you go transition your infrastructure, you can actually also go and use it as a migration tool. So you could pretty much set this up with your VMs. And then as you chop up your monoliths or as you containerize your services, you could just move them piece by piece. And then the other thing is, this is what Istio and Envoy look like together. So same model, there's a control plane. There's a data plane, which is with service A, service B, and then the proxy there. So typically, we use Envoy proxy, but any XDS we do compliant proxy can be used. Now, if you just imagine this picture and you put traffic director in the mix, what you will notice is this, that whatever capabilities you get out of pilot, you can put traffic director there. And that is one of the main reasons we chose to keep the interface between traffic director and the proxies using open source APIs, because in the future, you will be able to just go substitute your open source pilot using the traffic director. And then, like, if there is one takeaway you probably took away from this conference, it's that Google and Google Cloud are all in on hybrid. And so we want your hybrid services to get the same benefits that any of your GCP services get, which is specifically as it relates to services management infrastructure. And so we want to provide traffic director such that it can not only manage the proxies and talk to the proxies and provide global load balancing for things in Google Cloud, but also for things on-prem. So, and then this is the picture you probably saw on the keynote day, which is bringing all of these pieces together. And this is how traffic director, Envoy, and then some of our existing technologies, such as multi-cluster ingress, which under the hood has our global load balancer, all of these fit in together. Because at the end of the day, what you really need is not point products that you stitch together. You need a whole suite of products, or rather a platform that can help you go and build all of these, like whatever services you want to build, whether it's on VMs, whether it's on containers, whether it's on-prem, in GCP, and other cloud. You should be able to do it the same way with ease, and then in a way that takes away all the toil from your end. So, I took you through a whirlwind tour of all of this. I now want to start with where this all began. And so please join me in welcoming Anna Berenberg from Google and Matt Klein from Lyft, who I get the pleasure of asking really difficult questions. After our talk, they will be available outside to talk to you, so feel free to bring in your questions. And I also wanted to give a special shout out to the people who helped me build these questions. These are all crowdsourced. So I'm going to probably take one of the slots. Do you folks have a mic? OK, I'll take this one. So let's start with the most popular question I got asked. So maybe let's start with Matt. Matt, why don't you tell us about yourself? But the popular question was not that. It was, tell everybody one thing that they don't know about you.
OK. Hi, everyone. Thanks for having me. I'm Matt, obviously. I've been at Lyft for about 3.5 years, where I work on networking. Prior to Lyft, I worked at Twitter, also on networking. Before that, worked at Amazon on EC2. So I've been working in the infrastructure space for over 10 years. Let's see. One thing that people don't know about me, I have a very unhealthy obsession with pickles, and I've been known to eat so many pickles that then I have to go drink a bunch of water because I have like a salt overdose. So don't give me pickles.
Hi, my name is Anna Berenberg, and I've been software engineer for 27 years. In the last 20 years plus, I work in networking industry, and I never wrote a line of networking code. I always had interest in building fault-tolerant, high-availability distributed systems and process management, system management, stuff like that. And then I joined Google 12.5 years ago and spent last 9 years in infrastructure and technical infrastructure, and without moving my desk, I moved into cloud 3 years ago, becoming responsible for all cloud load balancing and Google load balancing products. One thing people don't know about me, I used to dance professionally, ballroom dancing.
We might have time for that at the end. Okay, so that, and yeah, you guys have the mic, right? Okay, so actually this question is for you, Matt. Let's start with you, because I generally assume that most people would know about Envoy and what the journey was. But what we really wanted to do was a lot of people were very interested in hearing the journey in your own words. So how did Envoy start? And what were the exact problems you were trying to solve? How did it all begin?
Sure. So I've been working on service architectures for quite some time. Like I was saying, over 10 years now. So I've seen how Amazon had kind of solved these different problems that people are facing, how it had been done over Twitter. And I think what I mostly tell people is I think most people that are rolling out microservice architectures, it sounds great. We're obviously told to go and do it for all of the human scaling benefits, but we sometimes gloss over all the complexities that come from actually doing that. So I think a lot of smaller companies that aren't Google, they go and they start to roll out microservice architectures, and they wind up in a situation where they might get 10 or 20 services, and then things start getting really difficult because they're facing common problems in networking with observability. And what we found at Lyft, which is what I think a lot of companies face, is that they go from their monolith, they start rolling out microservices, and then the developers don't trust the actual microservice platform. And you wind up in this horrible situation where you have services that people don't trust because they can't debug them, they don't understand what's going on, and then they start adding code to their monolith again. So you're in this awful situation of having services that people don't want to use and continuing to actually use your monolith. So the way that people have historically solved this problem is using libraries. So at Twitter, there was a library called Finagle. Google obviously has a library called Stubby. And there's other companies that have solved this. And that library does a bunch of common concerns around things like observability, load balancing, retries, timeouts. But the industry has moved to a polyglot architecture. And by that, I mean that the days of Java only are basically over. So people now are building services in 5, 6, 7, 8 different languages. So building a library in those 8 different languages that your company has to support is kind of a non-starter. So when I joined Lyft, Lyft was having all of these typical problems around networking, observability, load balancing, this kind of aborted microservice rollout. And I knew that we could do a better solution, and that was this out of process proxy system where you could put all of the complicated logic in there and provide that for every application language, and it kind of grew from there. It became very popular at Lyft. It was solving a lot of business problems, and we open sourced Envoy about two years ago, and nowhere in my wildest dreams would I have imagined that I'd be sitting here right now and we'd be announcing these products. It's been pretty incredible, but Envoy has been sweeping across the industry, so there's been a lot of other folks that have had common problems.
So how did you just decide to open source it? Was there any big agenda?
There's no big agenda, but to be totally honest, this is kind of the second time that I've built Envoy, at least to a certain degree. We did something similar back at Twitter, and I don't want to build this again. So two times is enough. Yeah.
That's a good reason. So I think, Matt, you bring a lot of expertise as you built out Envoy and so on. I know Anna personally because I work with her on a day-to-day basis, and I've seen her do something similar as it relates to services at Google. And maybe, Anna, I think what would be nice is if you've been there at Google for 12 plus years, and some of the experiences that you had building out services, but then also about Istio, how did we decide to work on Istio, and how does it fit in with Kubernetes and several of our other services as well?
So building, I worked in the last well, 12 years actually. I wanted to work on Gmail. Instead, I got assigned to group doing load balancing. And I thought, fine, I'll do 1 year and I'll go do something else. I'm still there. Why? Because it's such a fascinating problem. The way we solved it at Google, it's actually a control system that does a pretty sophisticated service that does global load balancing in a way that improves quality of life for the services we built for. For example, how do you protect against query of death? About how do you figure out that not all queries or requests are the same cost because some queries are more expensive than others? How do you make sure your backends will never overload? All of that needs to be thought through so the service developers don't have to, and they don't have to build some sophistication solution. All they have to do is worry about the business logic. So with all of that, my focus always been on the control side of load balancing. And so when I saw Matt's Envoy proxy, I realized that this is exactly the proxy I wanted to have. Why? Because it's API driven, and it's funny, it had very similar APIs to the APIs we had internally at Google between the control plane system, which does global load balancing, and the proxies themselves. So with that, when the idea of Istio came out, sorry, the traffic director is, thank you. Traffic director, it became a natural substitution for a pilot, because with the same APIs now we can build into Istio and make Istio available not only within a single GKE cluster, but make it horizontal and make it available across the whole GCP and on-prem and multi-cloud. And in multi-cloud, when we talk about global load balancing, first we were talking about Google services, then we start talking global load balancing within a GCP. And now when we're saying global, it means really global, worldwide, no matter where. That's where our aspiration is. Today we don't have it, but that's where we're going with it, that we're going to take traffic director and make it load balance anything, anywhere within an Istio environment, or actually within an Envoy environment.
Sounds good. So actually, coming back to you, Matt, we spoke, I just brushed through a lot of technical details of Envoy. I think a lot of people may not be familiar with things such as filters, or I know that observability is built into Envoy. Can you describe, let's say your top 5 features for which you see all your users using Envoy?
Sure. Yeah, I think that's a common question recently, which is why has Envoy become so popular? I think there's a couple of different reasons. I think the API is probably the number one reason. I actually, when I look at, from my opinion, one of the biggest technology successes that I've seen in the last couple of years, it's actually Proto 3. Proto 3, in my opinion, has been pretty awesome, just in the sense that the ability to go from a structured IDL to JSON YAML and back and forth, and that's how we do our new configuration now. So the API is the same as the config. It's super seamless. Like, you can use gRPC in any different language. You can write config files in YAML and JSON, and it all works the same way. And I think people really love that. So the fact that you can control Envoy either through local config files, or you can serve everything over a central management server, it's super flexible. So I think historically, with proxies like Nginx and HA Proxy, where people have had to ship around config files, and that works fine, but there's, at large scale, trying to manage those files and make sure the updates take place and kind of figure out how to do that from a deployment perspective can be quite complicated. So the API has been very flexible and has been super popular. The other thing is the extension capabilities. So when I first designed Envoy, I kind of based it on prior experience, and instead of making it very HTTP specific, I built it in a way where it was an L3, L4 proxy. So basically bytes in, bytes out. And that means that it could be used for other protocols. So at Lyft today, we use it for MongoDB. We use it for Redis. There's people now building Thrift support, MySQL. We'll do Kafka eventually. And what you'll find is that even in all these protocol implementations, there's a lot of common core stuff around service discovery, health checking, so lots of common functionality can be shared, and then you can build these protocols on top. And then we also allow extensions at the HTTP layer, at the stats layer, at the tracing layer. So it's a pretty rich platform from an extensibility perspective. So I think from a technology perspective, those are the two main reasons. Third reason is just from a developer productivity perspective. I'll be honest in saying that we're the first open source proxy where we're on GitHub, like we do CI, we have a very open community. So I think people have really loved the fact that we're very easy to engage with and get patches in. So I think those are the big three reasons.
Great. And Anna, do you, similar to how Matt did a little bit of deep dive into some of the features, can you, whenever we say, we have a global load balancing, for a lot of people, it's this vision of a box or like a global box, which is like this huge thing. I know it's not that at all. Can you describe a little bit about what is this traffic director thing under the hood? What does the architecture look like?
So if you think about traffic director, it has two interfaces. One interface to the proxy, and it's open XDS APIs, and they have several APIs in them: cluster discovery service, endpoint discovery service, listener discovery service, route discovery service, health discovery service eventually, load reporting service, secret discovery service. I'm running it. So basically, it's all the communication that needs to happen between the proxy and the control plane. Now, on other backside, Traffic Director has interfaces to Google systems, our proprietary systems, that actually do all that functionality. We have a control system that does global load balancing in a way that there is nothing in the industry where we actually load balance based on a capacity of the backend. So we don't do spray and pray. We actually count the queries. And so we never deliver more than customer wanted us to deliver. And then we auto-scale, for example, based on that capacity. In addition, we do centralized health checking. So what is centralized health checking? When I joined Google, one of the biggest consumer in Google Cluster was a health checking, because when the deployments get big, if you start doing N-square health checking, the bandwidth consumed by health checks is enormous. So all of that sounds like, that's not a problem. It actually becomes like very boring health checking becomes a massive problem because it consumes all your network. So centralized health checking allows you to dedicate health checker and health check all backends in a way that it's actually health check. You can trust the result. The results are getting merged and aggregated by control plane, and then they're distributed with endpoint discovery service. Same with auto-scaling. We take all that data reported through load reporting service, and we digest it and we translate it into the demand that autoscaler needs to get, and we integrate it with autoscaler, and the autoscaler scales up based on traffic demand. So yeah, and the funny thing that I was telling Matt, that our internal APIs actually matched very closely to the Envoy APIs, and that persuaded me that that's the right proxy to use.
Sure.
Yeah, I think that when most companies look at deploying a proxy like Envoy or like HA Proxy or Nginx, most companies start with a fairly simplistic control plane. And if you even look at what Lyft does compared to what Google does, it's obviously a totally different magnitude of scale. So it's not surprising that we do things in a far less sophisticated way. But what I'm so excited about, just this whole general area, is that just because of this open API and the fact that people are converging on this API, it'll allow companies like Lyft eventually, who frankly are not going to be able or really can justify building a control plane as sophisticated as what Google can offer. We can just go and use that control plane. And I think there's tons of companies out there that would benefit from this type of technology. And it doesn't have to, from a Lyft perspective, we can still run our own envoys and still manage them and still do what we want with them. But we can get, far more sophisticated functionality from a health checking perspective, from a subsetting perspective, than we would ever be able to build ourselves. So that's super exciting.
That's awesome. I think, while both of you were speaking, like you were talking about Google and Lyft, a lot of people here have their own deployments, which likely are on-prem. Many of you are moving or have moved to GCP. And a lot of your services are probably in VMs, but you do want to containerize them to get all the benefits. And then in all of this, we added things like Envoy, Proxy, Istio, Traffic Director. So for people who are starting out here, at least, or based on your experience with your users, how do people bring in these new technologies into brownfield or existing deployments?
That's tough, and it really depends on the particular deployment. I think what's interesting from an Envoy perspective is that there's such a rich ecosystem of projects that are kind of starting to be built on top. So obviously Istio is super well known. There's a bunch of other companies that are building stuff on top. So kind of what I tell people these days, at least from an Envoy or from a Proxy perspective, is that I would not recommend that companies go and build their own control plane. Like, I think at this point, people should be looking at Istio, looking at Pilot, looking at other solutions that are out there, just because I think people underestimate the complexity of building your own control plane. I think people look at it and they're like, oh, how hard can it be? I can get some host information and send it to Envoy and things will just work. And it does do that in the beginning, but then as you start scaling up and you deal with the n-squared health checking problem and you deal with security and like service manifests and all this other stuff, it gets complicated really quick. So I think my recommendation right now for people that are looking into these solutions is to, not necessarily even look at Envoy directly, but to look at some of the stuff that people are building on top. And one of the things that I've been seeing recently, and I really firmly believe, is that it's really amazing that Envoy has become so popular and it's getting very wide uptake. But at the same time, I think that in a couple of years, though Envoy will be used in a lot of places, I think most people won't know that they're using Envoy. Like, I think they're going to consume it as part of other products or other systems. So I would definitely encourage folks to look at some of the systems that are being built on top.
Anna, what about you? What do you think? We hear this all the time, where we have customers coming in with existing deployments. And let's say it's somebody who's running their services in a VM. How would you ask them to start, or where would they start?
So from our perspective, the configuration coming to Traffic Director is done via GCP API. And in the future, we add additional Istio APIs. But GCP API is already integrated with a lot. Those are load balancing APIs. You provision other load balancing products. And what we've done, we use the same data model to provision Traffic Director and Envoys. The only difference is a one Boolean. And so in my mind, one, it's easy, if you're already using GCP, it's easier to add on because it's just yet one Boolean and instantiation of Envoy. Also, we are going to be, because it's all integrated, Traffic Director essentially becomes a centralized brain for all your endpoints everywhere. So whether you're configuring Envoy, which is self-managed, or maybe managed, or some other product that is going to be using Envoy, or any, for that intent and purposes, any proxy that using the same APIs, we can extend your existing deployment to Istio or to just Envoy.
Sounds good. I actually wanted to give, because we want to hear from you. So I'm going to give you this hypothetical scenario. So let's think, let's say 3 years down the line. I don't like 5 years, so we'll go with 3 years. How do you, would we be talking so much about pain points of delivering hybrid services? Or do you think there'll be a slew of products and platforms, with this being a beginning, where it's just natural to have something that's across clouds? How do you see the world maybe 3 years from now? What kind of products, technologies? What is the next thing you'll be working on that'll help some of this stuff?
So from a 3-year perspective, that's tough to say. But I'll talk a little more, I think, in the 5 to 10-year time frame,
okay.
Just in the sense that I'm a big believer in serverless technologies. Serverless, just in the sense that I think most application developers, they want to write business logic. They don't want to worry about infrastructure. And the biggest thing that I see in the industry right now is that most companies they're spending too much time on a per developer basis worrying about infrastructure, worrying about how networking works or observability or databases. So I'm a big believer in the idea of eventually people writing functions or code snippets and eventually being able to just ship those. With that said, I think we're very, very far from there, just because I think a lot of those technologies, they're orders of magnitude more complicated than what we have today. There's more auto scaling, there's more networking, there's more problems that can happen. So where I see things going is, I think that increasingly all of the cloud providers, not just Google, are going to start offering more integrated products where, you might not call it serverless, it might be container-based, but the idea is that, people are going to expect a certain set of technologies around observability, service discovery, load balancing, rate limiting, policy, RBAC. And instead of having to worry about how it's implemented, people just want to show up and say, I'm going to use these features. So I'm biased. I think Envoy will be used to deliver kind of those use cases. But as I was saying before, I don't think many people will end up knowing that it's Envoy that's actually doing that. They're going to use integrated products. So right now, from a hybrid perspective, obviously we're going to have years of people who have on-prem or in multiple clouds. But over time, I think we're going to move to hosted Kubernetes, and then from there we're going to move to hosted function platforms, and it's going to be a slow iteration, but we just keep adding more abstractions, and hopefully every year people have to deal less with infrastructure.
I probably want to talk about even higher level of abstraction. I think in 3 years, maybe in 5. People stop configuring system as they are today via APIs, via these YAML files and everything, because we just need to not make infrastructure, the service owners to be having PhD in provisioning. So all we want to do is actually to move towards intent-driven configuration where the service can be described into intents. Do you want to have a service with latency optimized to optimize perceived user latency from the user to the front end or overall serving? Or the other one, do you want to have cost optimized service? Or do you want to optimize towards transferring less data over wire or something else? These are the configuration that will internally translate into right configuration. Because today with the hundreds of knobs, even with your best intent, you may not end up with the intent you want to have. So we need to be able to express intent very clearly in a high level and translate it internally. And the second thing, I think, super important, to stop thinking about each microservice separately. We need to start thinking about overall deployment and how to have configuration or policies that apply to overall deployment. How to provide consistency and coherency to make sure that if you're talking about security policies, you don't have to go and configure on each of 180 microservices. All you have to say, I'm going to provision it one way, and then it's going to understand how to apply it everywhere in the different ways, however service is deployed. And then it's actually, then you can link it into some recommendation engine that can say, oh my God, you didn't provision something somewhere, or you have vulnerability about security. Or in general, it can look at the deployment and can say you can do better, right? I think that's where we want to be in 3-5 years.
So I think with that, we come to a close of this session. Matt and Anna will be here, I think, probably outside the room. So feel free to reach out. The nice thing is a lot of these are very new technologies. And the reason we are talking about them so early is because we do want each one of you to influence these technologies. And we added a set of features that we thought were table stakes. But I'm sure there are a lot more features that you need on your end to make this just be the tool to make your hybrid and multi-cloud deployment seamless. So with that, thank you, folks, for coming. And feel free to talk to our two people and ask them all the tough questions. Thank you, everyone.